There are few moments when your life is not steeped in memory. Memory is at work with each step you take, each thought you think, and each word you speak. Through memory, you weave the past into the present. In this lecture, we explore the key processes of memory, including how information gets into memory and how it is stored, retrieved, and sometimes forgotten. A penny for your thoughts. Which of these drawings of a 1-cent coin is accurate? If you're like most people who have taken this simple memory test, you probably won't answer correctly. Fortunately, recalling the head of a penny is not a life or death matter. But what if you were being asked to remember the face of a criminal? An accurate recollection would be more crucial, but according to new research, no more likely. Recent findings show that memory is a lot more fallible than we think, and specifically that eyewitnesses' recollections of crimes and accidents are often very unreliable. Researcher Elizabeth Loftus said, "We store bits and pieces of information, and when it comes time to retrieve, we take bits and pieces of our experience from different times and we integrate it." Studies have shown that crimes are particularly hard to remember because such factors as fear, stress, surprise, and violence can get in the way of accurate observation. Dr. Loftus notes, for example, that if you see something violent, it can cause retrograde amnesia, a forgetting of details that occurred prior to the eruption of the violence. And she also points out that factors such as eyesight, hearing ability, prior knowledge, and prior expectations can distort what is seen, heard, and committed to a person's memory. Back to the penny test. The correct answer is A. But don't feel too bad if your guess was wrong. When research psychologists Raymond Nickerson and Marilyn Adams gave the test, fewer than half of their subjects got it right. Psychologists define memory as the retention of information or experience over time. Except for the annoying moments when your memory fails or the upsetting situation where someone you know experiences memory loss, you most likely do not consider how much everything you do and say depends on the smooth operation of your memory systems. This lecture is divided into three main parts: the three-stage model of memory, encoding information into memory, and retrieving information from memory. Most psychologists distinguish among three major systems of memory: sensory memory, short-term memory, and long-term memory. These systems serve different purposes and vary along at least two important dimensions: span, how much information each system can hold, and duration, over how long a period of time that system can hold information. We can think of these three systems much like the different factory workers along an assembly line. The first system, sensory memory, is tied closely to the raw materials of our experiences, our perceptions of the world. It holds these perceptions for just a few seconds or less before passing some of them on to the second system. This second system, short-term memory, works actively with the information handed to it, transforming it into more meaningful material before passing some of it on to the third system. Short-term memory holds on to information longer than sensory memory does, but not much longer. The third and final system, long-term memory, permits us to retain information for minutes, days, weeks, months, or even years. In some cases, the information in long-term memory lasts a lifetime. Here's a visual representation of the three-stage model. Information from the physical environment enters the sensory registers through each of our senses: vision, hearing, taste, smell, and touch. This set of registers is referred to collectively as sensory memory. These registers are temporary storage places for sensory information until it can be attended to, recognized, and moved further along in the memory system. Sensory information that is not attended to is quickly forgotten. The information in each register that we attend to goes on to be recognized and enters the second stage of memory, short-term memory. If attended to and studied, information in short-term memory will be encoded into long-term memory where it is stored for later use. If not attended to, the information will be forgotten. To use the information stored in long-term memory, we bring it back into short-term memory, a process called retrieval. If we cannot retrieve such information, it is said to be forgotten. Later in this lecture, we will consider explanations for such forgetting. Sensory memory consists of a set of 5 registers that serve as temporary storage places, one from each sense. It's used for incoming sensory information from the physical environment until we attend to it, interpret it, and it proceeds to the next stage of memory. Sensory memory allows the sensation of a visual pattern, sound, or touch to linger for a brief moment after the sensory stimulation is over. In the case of vision, people really perceive an after image rather than the actual stimulus. The brief preservation of sensations in sensory memory gives you additional time to try to recognize stimuli. However, you better take advantage of sensory storage immediately because it doesn't last long. Because the image of the sparkler persists briefly in sensory memory, when the sparkler is moved fast enough, the blending of after images causes people to see a continuous stream of light instead of a succession of individual points. Iconic memory, from the word icon, which means image, refers to visual sensory memory, which is retained for only about 1/4 of a second. Visual sensory memory is responsible for our ability to write in the air using a sparkler on the 4th of July. The residual iconic memory is what makes a moving point of light appear to be a line. The sensory memory for other senses, such as smell and touch, has received little attention in research studies. Iconic memory is an exact copy of visual information, and it's less than a second in duration. It has a very large capacity. Now just think of a cartoon movie, which is nothing more than a series of still drawings flashed in rapid succession. Iconic memory allows us to perceive motion in those drawings. Researchers have tested iconic memory through the temporal integration procedure. Temporal relates to time. This involves giving 2 random meaningless dot patterns sequentially at the same visual location with a brief time delay between the 2 presentations. And it creates a meaningful pattern when the 2 patterns are integrated somewhere in the memory system. The time delay between the 2 presentations must be no longer than 1 second, or no meaningful pattern can be perceived. Here's an example of this experimental procedure. 2 meaningless patterns, such as A and B, are shown sequentially at the same visual location. If the time interval between the 2 patterns is less than a second, a meaningful pattern, in this example the letters VOH, is seen. The meaningful pattern can only be perceived when the 2 other patterns are integrated. So this integration must be taking place within our memory system in what we call the visual sensory register, or iconic memory. In testing iconic memory, George Sperling demonstrated that the memory trace in the visual sensory store decays in about 1/4 of a second. Sperling used full and partial report procedures. Participants were presented with a different 3x3 matrix of unrelated consonants for 50 milliseconds across numerous experimental trials. In the full report procedure, participants had to report the entire matrix. Participants sensed the entire matrix but could not report all 9 letters. In the partial report procedure, participants had to report only 1 row of the matrix. An immediate auditory cue resulted in successful recall. A 1-second delay resulted in poorer recall. Now, there is some debate about whether stimulus persistence really involves memory storage. Some theorists view it as an artifact of the perceptual processing of incoming stimuli that is attributable to excitatory feedback in specific neural circuits. In other words, stimulus persistence may be more like an echo than a memory. Here's a 3x3 matrix like those used in Sperling's iconic memory research. On each trial, a different letter matrix is shown for 50 milliseconds. In the full report procedure, participants attempted to recall all of the letters in the matrix. In the partial report procedure, participants get an auditory cue following the matrix that tells them which row to report. A high-pitched tone, recall the top row. A medium-pitched tone, recall the middle row. and for a low-pitched tone, you're to recall the bottom row. The row that is cued is varied randomly across trials, so the participant has no way of knowing which row will be cued on any particular trial. In addition, the time between the letter matrix presentation and the auditory cue is varied. Sensory memory is a helpful system because it buys our brains a bit of extra time to process incoming sensations. It also allows us to fill in the blanks in our perceptions and see the world as an unbroken stream of events. 3 or 4 bolts of lightning overlap in our iconic memory, leading to the perception of one continuous bolt. It is iconic memory that allows us to see the world as continuous and not as a series of unconnected snapshots. Much information goes no further than the stage of sensory memory. We retain this information only for a brief instant. However, some information, especially that to which we pay attention, proceeds into short-term memory. Short-term memory is a limited capacity memory system in which the information is usually retained for only as long as 30 seconds, unless we use strategies to retain it longer. Compared with sensory memory, short-term memory is limited in capacity, but it can store information for a longer time. Short-term memory is a memory stage in which the recognized information from sensory memory enters into consciousness. It involves present conscious cognitive processing, and it serves as a place to rehearse information. You surely have used the rehearsal process on many occasions. Say you get a phone number from directory assistance, and you might recite it over and over until you dial the number. Rehearsal keeps recycling the information through your short-term memory. In theory, this recycling could go on indefinitely, but in reality, something eventually distracts you and breaks the rehearsal loop. Now, short-term memory is also called working memory. It involves concentrating on information, or it will be lost in 30 seconds. Short-term memory has a limited capacity. Memory span refers to the average number of items that can be remembered across a series of memory span trials. Humans have a memory span of 7 plus or minus 2 chunks of information, and it's almost surely not a coincidence that telephone numbers in North America are 7 digits long, not counting the area code. Short-term memory is limited. The small capacity of short-term memory was pointed out by George Miller in a famous paper called The Magic Number 7 plus or minus 2, Some Limits on Our Capacity for Processing Information. Miller noticed that people could recall only about 7 items in tasks that required the use of short-term memory. When short-term memory is filled to capacity, the insertion of new information bumps out some of the information currently in short-term memory. The limited capacity of short-term memory constrains people's ability to perform tasks which they need to mentally juggle various pieces of information. Chunking is a way to combine information into meaningful units. It's long been known that people can increase the capacity of their short-term memory by combining stimuli into larger, possibly higher order units. Long-term memory allows storage of information for a long period of time, perhaps permanently, and it essentially has an unlimited capacity. Long-term memories are durable. Some information may remain in long-term memory across an entire lifetime. One point of view is that all information stored in long-term memory is stored there permanently. According to this view, forgetting occurs only because people sometimes cannot retrieve needed information. To draw an analogy, imagine that memories are stored in long-term memory like marbles in a bucket. According to this view, none of the marbles ever leak out. When you forget, you just aren't able to dig out the right marble, but it's there somewhere. In a survey of the general public's view on memory, 48% of respondents endorsed the idea that long-term memory storage is permanent. An alternative point of view assumes that some memories stored in long-term memory do vanish forever. According to this view, the bucket is leaky, and some of the marbles roll out, never to return. Memory researchers make a distinction between 2 major types of long-term memory: explicit memory, which requires conscious recall, and implicit memory, which does not. Each of these two major types of long-term memory is further subdivided into more specific types of long-term memory as defined in the figure, and we'll take a look at these in the next slides. Explicit memory, also known as declarative memory, is long-term memory for factual knowledge and personal experiences, and it requires conscious recall. Now, there are two types of explicit memories: semantic memories, which are memories for factual knowledge that is true for everyone, for example, knowing the current president of the United States, and episodic memories, which are memories for personal life experiences, for example, your senior prom night. All right, let's take a look at implicit memory, also called non-declarative memory. It's long-term memory that influences behavior but does not require conscious awareness or declarative statements. For most adults, for example, it's driving a car or walking. Procedural or conditioned memories become automatic responses to certain stimuli, like feeling tense when police car lights are flashing behind us. For a tennis expert, such as Serena Williams, the movements of play are implicit, procedural memories, whereas for the average person, such movements require conscious recall and are more semantic memories. Procedural memories have a physical, procedural aspect to them. Priming involves implicit influence of an earlier presented stimulus on the response to a later stimulus. Let's say a subject is asked to read a list of words, including the word carpet. When later asked to complete a word starting with the letters C-A-R, the probability that he or she will answer carpet is higher than for non-primed subjects. Priming is different from explicit memory because explicit memory uses a more direct retrieval method. Priming is not located in the same place as conscious thought. Research has proven that priming can affect the process of decision making. It can also help people fill in the blanks. For instance, if you overheard someone say, "Boy, I just had the best red berries," you may be able to assume that the person just had strawberries because they are, in fact, red. This information is retrieved because red and strawberry are closely related in some people's minds. The type of memory retrieval is an automatic response to a situation. Therefore, it is defined as implicit. There are a couple of terms associated with amnesia that you need to be familiar with. Amnesics are people with severe memory deficits following brain surgery or injury. Anterograde amnesia is the inability to form long-term memories for events following brain surgery or trauma. And retrograde amnesia is the inability to remember events before, especially just before surgery or trauma. Now, the general public holds a host of misconceptions about amnesia. Perhaps the most prevalent myth is that people with amnesia have lost all memories of their previous life, even of who they are. In fact, such generalized amnesia is exceedingly rare, although it's a favorite plot device of Hollywood movie makers. Another myth, also perpetuated by Hollywood, is that memory recovery from amnesia is usually abrupt. Although sudden recoveries from amnesia make for good drama, they don't make for good science. In fact, memory recovery from amnesia tends to occur gradually, if at all. A final myth is that most people with amnesia suffer primarily from retrograde amnesia. In fact, anterograde amnesia is a far more common and troubling problem. By far, the best-known person with amnesia in the psychological literature was a man from Connecticut, known only by the initials of HM, who suffered from severe epileptic seizures that his doctors couldn't control with medication. In March 1953, in a last-ditch attempt to eliminate these seizures, surgeons removed large chunks of HM's temporal lobes, including both his left and right hippocampi, where they had reason to believe that the seizures originated. Now, the surgeons of the time didn't anticipate the disastrous impact of this radical operation, which would probably never be performed today. At the time, HM was 26 years old. Following the operation, HM developed virtually complete anterograde amnesia. He could recall almost no new information. HM read the same magazines and completed the same jigsaw puzzles over and over again without any awareness of having seen them before. HM's tragic case also illustrates a striking dissociation between explicit and implicit memory. Researchers asked HM to trace simple geometric shapes from a mirror, a task that just about all people find infuriatingly difficult when they first try it. The task is to trace the outline of a star or some other shape with a metal stylus when the star and your hand can be seen only in the mirror. The tracing movements have to be made in the direction opposite from the way in which they appear in the mirror. Now, when the stylus moves off the star outline, each red section in the illustration, it makes electrical contact with an underlying aluminum plate, and a tracing error is recorded. There is non-conducting tape on the star outline, so as long as the stylus stays on the outline, no electrical contact is made. Now, just like we would, HM improved from session to session. The number of errors he made decreased as he gained more experience in this task. However, unlike us, he could not remember ever having performed the task before and had to have the task explained to him at each session. As explained in the text, this means that he formed new implicit procedural memories for how to do the task as his performance improved over time, but he did not form new explicit episodic memories of having performed the task. What is the very first memory you can recall? You were probably 3, 4, maybe 5 years old. I can remember riding a tricycle, and I remember it was green and white, and I was riding it on the patio behind our apartment. That's the first explicit memory I can recall, and there's a reason for that. The hippocampus seems to be important for the formation of explicit memories, and it doesn't fully develop until about the age of 3. This explains why we cannot remember as adults events that occurred prior to this age. During infancy, neurogenesis levels are high because the hippocampus is developing, and researchers found evidence that such high levels of neurogenesis disrupt hippocampus-dependent memories, causing them to degrade. The next section of the lecture involves how we encode information in memory. And as we transition to the next section, I want to quickly review the memory system processes. First, there is encoding, the process of transferring information from one memory stage to the next. And then storage, the process of maintaining information in a particular stage. Finally, we need to get the information when we need it, and that's retrieval, the process of bringing stored information from long-term memory to the conscious level in short-term memory. The first step in memory is encoding, the process by which information gets into memory storage. When you're listening to a lecture, watching a play, reading a book, or talking with a friend, you are encoding information into memory. Some information gets into memory virtually automatically, whereas encoding other information takes effort. Let's examine some of the encoding processes. A factor that influences memory is whether we engage with information superficially or really get into it. Fergus Craig and Robert Lockhart in 1972 first suggested that encoding can be influenced by levels of processing. The term levels of processing refers to a continuum from shallow to intermediate to deep, with deeper processing producing better memory. Levels of processing theory describes what types of encoding lead to better retrieval. It contains 3 levels of processing: physical, how the information appears; acoustic, how the information sounds; and semantic, what the information means. Long-term memory is best for information encoded semantically, next best for information encoded acoustically, and worst for information encoded physically. Research has clearly shown differences in recognition memory for words processed at different levels. Participants were presented with a long list of words, one at a time, and had to answer a question about each word as it was presented. The nature of the questions led to different levels of processing. Physical, such as how was it printed, acoustic, how it sounded, or semantic, what it meant. The level of processing dramatically affected the participants' later ability to recognize the word as one that had been on the list, as you can see in the figure. Effective encoding of a memory depends on more than just depth of processing. Within deep processing, the more extensive the processing, the better the memory. Elaborative rehearsal refers to the formation of a number of different connections around a stimulus at any given level of memory encoding. Elaboration is like creating a huge spider web of links between some new information and everything one already knows, and it can occur at any level of processing. In the case of the word mom, a person can elaborate on mom even at a shallow level, for example, by thinking of the shape of the letters and how they relate to the shapes of other letters. Say how an M looks like two N's. At a deep level of processing, a person might focus on what a mother is, or might think about various mothers he or she knows, images of mothers in art, and portrayals of mothers on television and in film. Generally speaking, the more elaborate the processing, the better memory will be. Deep, elaborate processing is a powerful way to remember. It provides more retrieval cues to facilitate retrieval, and it contrasts with maintenance rehearsal, which is simply the repetitive cycling of information in short-term memory. The self-reference effect contends it is easier to remember information that you have related to yourself, and it suggests that such connections provide more retrieval cues and lend more meaning to the new information. That is why our discussion questions in this course ask you to share personal examples so that you can better relate to the material and remember it. We also need to consider environmental effects on encoding. The encoding specificity principle proposes that cues present during encoding serve as the best cues for retrieval. This is why participation in the discussions is so important. The various concepts and examples that you relate to a new concept during elaborative rehearsal will help you remember the concept. State-dependent learning depends on the relationship of one's physiological state at the time of encoding and at the time of retrieval. Rats taught to run a maze under the influence of a depressant drug will often forget the route through the maze if tested later without the drug. Given the drug again, they retrieve their memory and run the maze successfully. This is called state-dependent memory or state-dependent learning. The assumption made by the researchers is that the animal's state of mind affects the encoding of the memory. When the same conditions are reinstated, it helps memory retrieval. Alcohol-related state-dependent memory is known to occur with humans. Heavy drinkers may forget what they did while drunk, only to remember again the next time they drink. This phenomenon has been documented under experimental conditions using word lists. A couple of other environmental effects on encoding are mood-dependent memory effect and the mood congruence effect. The mood-dependent memory effect demonstrates that memory is better when a person's mood is the same during encoding and retrieval. For example, if you are happy during encoding information, it is easier to retrieve that information if you're happy at the time of retrieval. The mood congruence effect demonstrates that memory is better for experiences that are congruent with a person's current mood. In other words, when we are sad, it is easier to retrieve negative events in our lives. Now we've reached the last section of the lecture, retrieving information from memory. Human memory has its imperfections, as we all have experienced, and it's not unusual for two people to argue about whether something did or did not happen, each supremely confident that his or her memory is accurate and the other person's is faulty. We all have had the frustrating experience of trying to remember the name of some person or some place, but not quite being able to retrieve it. In this section, we look at retrieval, why we forget, and the reconstructive nature of retrieval. Psychologists have studied how we retrieve information from memory in many ways and have measured it in a couple of different ways. One is recall. the measure of retrieval that requires reproduction of the information with essentially no retrieval cues. Recognition, the measure of retrieval that only requires identification of the information in the presence of retrieval cues. And relearning, also referred to as the savings method, a measure of the amount of time saved when learning information for a second time. One of psychology's pioneers, Hermann Ebbinghaus, was the first person to conduct scientific research on forgetting. He conducted the first experimental studies on human memory more than 100 years ago using the relearning method. He mastered and relearned a list of nonsense syllables like ZEQ, XID, and RIY. He would study this list until he could correctly recite the complete list without hesitations. Then he put the list aside and waited some period of time, and then relearned the list with the same criterion. To get a measure of learning, he computed a savings score, the reduction in the number of trials it took him to reach criterion. The result? The forgetting curve reveals that most forgetting occurs in the first 2 days after learning the material. The course of long-term forgetting usually takes on the shape of this figure, a rapid steep decrease that then levels off. In Ebbinghaus's memory research with nonsense syllables, the amount of time he saved relearning the material decreased dramatically for the first 2 days following initial learning, and then leveled off after that. It looks like we forget a lot rather quickly, but fortunately researchers have demonstrated that forgetting is not as extensive as Ebbinghaus envisioned. Ebbinghaus studied meaningless, nonsense syllables. When we memorize more meaningful material, such as poetry, history, or the content of this course, forgetting is neither so rapid nor so extensive. Sometimes when people say they have forgotten something, they have not really forgotten it. Rather, they never encoded the information in the first place. Encoding failure occurs when the information was never entered into long-term memory. As an example of encoding failure, think about what the U.S. penny looks like in the example at the beginning of this lecture. Now, unless you are a coin collector, you probably have not encoded a lot of specific details about pennies. You may have encoded just enough information to distinguish them from other coins. The penny exercise illustrates that we encode and enter into long-term memory only a small portion of our life experiences. A couple of theories attempt to explain why we forget. One is encoding failure theory. It contends that sometimes forgetting is not really forgetting, but rather that information was never entered into long-term memory in the first place. Storage decay theory suggests that forgetting occurs because of a problem in the storage of the information. The biological trace of the memory gradually decays over time, and the periodic usage of the information will help to maintain it in storage. I have forgotten most of the French I took in college. I took French in high school and 4 semesters in college. Now, storage decay happened because I haven't used it. It's the use it or lose it idea. Another reason we may forget is interference, and one type is proactive interference. It occurs when information you already know makes it hard to retrieve newly learned information. Think about changing phone numbers after having a certain number for many, many years. When asked for your new phone number, remembering the old one interferes with retrieving the new one. Retroactive interference occurs when information you just learned makes it hard to retrieve old information. Now think about being at a party with many people you don't know. You meet someone whom you'd like to talk to later, but after meeting her, you are introduced to many more people. Now you can't remember her name. Here's another example of the types of interference that can occur, and this actually happened in my life. I studied French in high school and college, and later in life met a very special lady who was originally from Mexico and decided that I really needed to learn Spanish. In the proactive interference example, my prior learning of French disrupted memory for newly learned information, which was Spanish. She would say, ¿Qué tal? And I would say, Très bien. In the retroactive interference example, the new learning, Spanish, disrupts memory for information learned earlier, French. A very important idea in this module is that memory is reconstructive. Our minds are not like tape recorders or video cameras. Retrieval reconstruction is guided by schemas. Schemas are organized frameworks of knowledge about people, objects, and events that tell us what normally happens in a given situation. Schemas allow for more efficient information encoding and retrieving. Schemas can lead people to misremember information so that it is more consistent with personal schemas. Now, information that really clashes with a schema may attract extra attention and deeper processing and thus become more memorable. But let's say you go to a doctor's office. You have a schema of, you may not remember everything that is in the office, but you have a general idea of the things that are in the office. But let's say, for instance, you saw a slot machine in a doctor's office. You would probably remember that. A survey on people's notions about memory found that 63% believe that when you retrieve information from long-term memory, you're able to pull up a mental videotape that provides an exact replay of the past. However, countless studies have demonstrated that this is a naive and extremely inaccurate view of memory. In reality, all memories are reconstructions of the past that may be distorted and may include details that did not actually occur. False memories can occur because of the misinformation effect, which occurs when a memory is distorted by subsequent exposure to misleading information. The misinformation effect, which has been replicated in countless studies, is a remarkably reliable phenomenon. Indeed, the effect is so difficult to escape that even subjects who have been forewarned can be swayed by post-event misinformation. A practical application of psychological research on memory can be seen in eyewitness testimony and memory. False memories do occur and suggest that eyewitness testimony is subject to error and can be manipulated by misleading information. Eyewitnesses sometimes provide invaluable evidence, especially when they have ample time to observe the perpetrator under good lighting conditions, when the criminal isn't disguised, and when little time elapses between witnessing the crime and identifying the guilty party. But eyewitness testimony is far from accurate when these optimal conditions aren't met. Moreover, eyewitness testimony is less likely to be accurate when people observe individuals of races different from their own. Research also shows when they talk to other witnesses and when they catch only a brief glimpse of the criminal, or when they see a crime under stressful circumstances, such as when they feel threatened, they can develop inaccurate recalls. Psychologists can play a crucial role in educating jurors about the science of eyewitness recall so that they can better weigh the evidence.